Okay, today topic is electronic signal and the systems in the process control system. So in the process control system, we use the electrical control, mechanical control, hydraulic control, thermal control, those control systems we use. So normally the information produced by your system will be the mechanical system or thermal system, temperature. Those are converted to the electrical signal. So especially the electronic signal by the transducer. So the transducers are convert the temperature to the electronic signal as well as the pressure to electronic signal. So those signals are processed. So those signals need to be transmitted to the controller. So in this case, those standby signals will be weak. So those signals need to be amplified by the amplifier. And there's a controller system that controls those signals. And the feedback signals are provided back to the system. So because of this one in the process control system, there will be the electronics how the signal will be transferring, how you control the signal, how will be the control loops are working. Those are kept to be steady. So today's topic is the electronic signal system. So in this topic, I will focus on what kind of signals can be produced by the transducer and how can be transmitted or how can they be the transfer or how can they be the control. Those things has to be steady in the electronic signal system. This is the input transducer system. So input transducer functions to convert the information from source to input signal. So information can be the mechanical or thermal or hydraulic. So those are the source to the electrical signal by the input transducer. Then the transmission media, so there will be the data communication network. And so we supply we amplify those signals by amplifier. So those are the for the system. Okay, so for example, we can see that power distribution system. We can see a typical process control system for the power distribution. Power distribution system. So input power with the mechanical energy. So mechanical energy will use the input power. So input transducer will use the generator. Then we use the generator. So input transducer is generator. So the generator will cause the losses. And then we also supply to the transmission system. The transmission system can also have the losses. So this is power transmission line, and then the output transducer will be the motor. So this is the losses. So this is for motor. So finally, the output power can be supplied with the useful output. So this is a typical process system. Process system means the inputs of mechanical energy can be the steam turbine, water turbine, diesel generator. Steam turbine, water turbine, and a diesel generator. So those are the input transducer. Input transducer mechanical energy. So mechanical energy is drives the input transducer generator. So generator convert the mechanical energy to the electrical signal, electrical voltage. So these electrical voltage are transmitted over the transmission line, and then we supply to the output transducer. Output transducer will use a motor. So motor will provide the output transducer. So this is for the power distribution system. So power distribution system input to output is converted. So this is a typical process control system. So this process control system will be in this case sometimes we have to run the specific voltage and frequency. So in this case we have to regulate the input. So that in the control system, we sense the output power here, then just giving the controller, and the driver input machine. So this is by this way you can produce the closed loop control system. So that in the system, the output will be we have to check the appropriate voltage level, appropriate frequency level. So the frequency higher or lower, in this case, input the machine drive system need to be regulated so that the controller function is a drive back and the regulated input system. So in this case, we can use the open loop and the closed loop control system. So normally, without the controller, there will be open loop control system. When you provide the controller, there will be the closed loop control system. So that we can see that closed loop and the open loop. So firstly, we can talk about the negative feedback amplifier. Negative feedback amplifier is here. The input signal, the positive negative input with the VS, the source voltage, and output with the VR. The output voltage coming out. So that here we can use the feedback loop. So this is the resistor R1, resistor R2, and the resistor R1. For the feedback loop and it's connected to the ground for the chain. So this feedback loop here you connected to the feedback signal provided. So that will be the voltage with the VS. So feedback voltage. So this feedback voltage you can calculate. The feedback voltage you can calculate by the equation. VF is equal to the R1 divided by R1 plus R2 into VR. By this way you can calculate the feedback voltage. So output voltage sampled by the resistive voltage by that to produce the feedback. The voltage compared separate from the original input signal and different amplified. This is for the negative feedback amplifier. So this is for the typical control loop system. So output voltage is a takeout of the sample and the make the comparison and they control the input function. Amplifier gain. So amplifier gain is a fractional output voltage to feedback. So VF divided by Vout is a B. So we can write the equation. So in this case we can write the amplifier gain. So it's an A. So this is V out and a V in. And also there's a V. So VF divided by V out. A is the amplifier against V out. The ratio between the output voltage and input voltage. And also there's we can also calculate for the V. V is the ratio between the feedback voltage and the output voltage ratio. So in this case we can how to make the control system. So we modify this circuit. This circuit is just a basic principle. So amplifier. So in the VF control system, we need to modify the circuit. Okay, so this is for the modification. So this is positive and negative here. So this is we use a control potentiometer. So this is negative and a positive. So this is control potentiometer. Control potentiometer. So control potentiometer, so we got the circuit controller here, and this is a negative voltage. So negative voltage we can supply to the output motor. This is a motor. This output motor, also this motor drive the servo motor. The servo motor drive the this is the adjustment terminal. So this one is a drive by the servo motor. So this is a potentiometer positioned by motor. So this is the two control system. The input voltage can be controlled, and the output voltage is you can take out the potentiometer, the positioned by the motor. So this is the motor can be the servo motor. So by this way, it can take the sample from the output voltage, and we can make the comparison and do amplify the different signal and try the motor. So this is the typical control system. So the position share is the control of the potentiometer. The amplifier adjusts the position share until the potentiometer and the position setting, the potentiometers are equal. 对不对？到we need是here we need的equal body。So the equal between these two terminals, positive and negative terminal of the operational amplifier, until we got the equal body at the positive terminal, negative terminal, which are position is adjusted by the carbon water. This is for the position. The position of the shell is controlled by the potentiometer. The amplifier adjusts the position of the shell until the control potentiometer and the position sensing potentiometer are equal. So the important one is that the signal set in the positive and negative terminal of the operational amplifier must be equal. So until it's got equal, this motor drives this carbon water drives the position. And this body can be sensed, and so these two bodies are equal, so that we can finish the control function. So by this way, we set the control. So the any system, power system, or any drive system, we ever need to take the control. So the sometimes the output speed or the output voltage will be higher than the normal value. In this case, we have to provide a negative feedback system. So this is a typical basic idea of the negative feedback system. So that when you put the switch control, the important one is that this controller got the inertia. Controller got the inertia or the controller got the sample restriction. Because of this one, all those are input signal. You supply the input signal with the square wave, output will be the same as the input signal due to the inertia effect. This system, they are affected by the inertia. Especially the feedback amplifier, they ever have the capacitance. So all the wires, so this wire carrying the positive voltage and the negative terminal, so those are the capacitance. The capacitance affect the output signal. So that all those are input is the square wave function, output is not square wave function because of the inertia effect. So we can see that the input here. So input signal. So we can provide the input signal this waveform, but the output is not the same when we like it. So this is the positive output response. Positive output response. Or there's sometimes you can provide a response like this. Or sometimes you can respond when you like this. Although input is we provide an input square wave function, output is the oscillation function can happen. So this is the damping effect. These damping effects are caused by the inertia for the mechanical system, for the electrical system, there will be capacitor effect. So because of this one, those signals you can see that those are oscillation signals. So this signal is also included as fundamental plus a harmonic frequency. So electronic signal system, we need to analyze the harmonic frequency. So those harmonic frequency need to be analyzed, and those harmonic frequency need to be eliminated. So in this case, we have to utilize the appropriate filter to eliminate the harmonic system for the electronic control system. Okay. So normally we use the electronic spectra and then non-linearity, time and the frequency domain. So traditional method of the observing the electrical signal is to view them in the time domain using the oscilloscope. So this is for the oscilloscope. We use the oscilloscope, so the signals are horizontal axis with the time axis and vertical axis and amplitude. So that we count the signal going in line with the time. So this is that we use the oscilloscope. Oscilloscope function is that we view the precision as the signals are viewing. But oscilloscope got a limitation. So oscilloscope is only the 50 Hz, 100 Hz, 1000 Hz, no problem for kilohertz, you can use, but the frequency higher than the megahertz level, so inside the oscilloscope got a digital amplifier, those analog of the digital amplifier, those amplifiers, they cannot amplify the very high frequency signal. So this is why the oscilloscope can be utilized for the low frequency. But for the very high frequency, you cannot use the oscilloscope to view those signals. So in this case, we have to use the frequency domain. The frequency domain is instead of using the time domain, we have to use the frequency domain. So frequency domain, the horizontal is the frequency, and vertical is the amplitude. So the equipment which use the frequency domains are the spectral analyzer. So spectral analyzer, they view the amplitude with the frequency. So there are two things. Also, we use the time domain signal, but spectral analyzer, we use the frequency domain signal. We use a computer function to convert the other power quantity to the electronic signal. So we use the feedback controller to regulate the you compare the output and the input. So in this case, there are two kinds of frequencies during method. One is the time frequency domain. So time domain method. Time domain method means that we use the oscilloscope. Oscilloscope is the time domain analysis. So in this case, horizontal it is the time, vertical it is the amplitude. So time domain analysis is suitable for the analog signal and the low frequency audio and digital waveform. But when the frequency is very high frequency, megahertz or the gigahertz, in this case, oscilloscope cannot follow at the low signal. So in this case, we have to use the frequency domain. Frequency domain with the horizontal axis is the frequency, and vertical axis with the amplitude. So this is the frequency domain. So vertical is the amplitude, and horizontal axis frequency. So here is this line. So the line will be the horizontal line. Horizontal line means this horizontal line can be moved to left or right when the frequency varies. And vertical lines are with the up and down. So this is the signal level. So the line moves up and down crossing the signal level. This is the vertical line. Horizontal line is moving right or left depending on the frequency variation. So this is the frequency domain analysis. So that all the frequencies are analyzed. You can see that two lines. Horizontal lines are moving or vertical line up and down. So horizontal line movement represents the frequency variation. Vertical line movement represents the amplitude variation. So time domain analysis, you can see this oscilloscope. How to read the oscilloscope? So I show the oscilloscope here. This is the oscilloscope skin. So this is a skin. So when you see the waveform like this, if you see the waveform like this, so how to calculate the frequency? Normally the amplitude you can calculate here. This one to this one. This is the number of the deviation and the number of both are the deviation, so you can calculate the amplitude. And then this waveforms are start point and the end point to one complete waveform. So one complete waveform, how many deviations? So you can call this one will be the time. So the frequency is equal to 1 divided by time. So we can calculate the frequency. So in this case, so you can calculate the frequency. So the frequency normally we calculate is 1 divided by so number of deviation. So this is so by the way we can read the frequency. That is for the oscilloscope thing. Particle slide. So this is the frequency analyzer. So this vertical line. So vertical line amplitude is a signal magnitude. So this one is a signal magnitude.
The analog doesn't give you a power.
That's only the frequency. The magnitude and time you can calculate from this horizontal axis. This is the reference axis. So the distance. This represents the frequency. So this one is the frequency. So the time you can calculate, time is equal to 1 by frequency. So this is by which you can read the analyzer. So frequency analyzer is different from the oscilloscope. Oscilloscopes are waveforms are usually shown, but you can see the waveform, whether your waveform is sinusoidal or square wave or sawtooth wave, you can use. But the frequency analyzer does not concern about the kind of the waveform, they only concern about the frequency. So frequency magnitude is a vertical line, so the distance from the 0 axis to the point vertical line is with the magnitude, frequency magnitude.
X-axis is a scale.
Scale, yes.
Relative to frequency.
Frequency, yes. Frequency.
Like it's mega, 1 mega, 3 mega, 100 mega.
Yes. So, yeah. So this frequency analyzer for the one advantage. So also, when you see the many frequency, also it's very confusing because there's so many waveforms are combining, so all waveforms are distorted like this. So that only one, two or three waveforms, only one waveform you can see the side by right? About two or three waveforms, all are combined, so that all your waveforms are like this. So they're very difficult to read. That this is a non-regular shape. So frequency analyzer system, you can see the difference of particle line. Particle line means that if you miss a many frequency, for example, this is the fundamental frequency F0, so another frequency F1, F2, F3, F4 like this. So the all frequencies are only one single line represents one frequency. So many separate lines represent a different frequency. So by this way, you can easily analyze the harmonic frequency or the fundamental value you can analyze. So this is why we use the frequency analyzer. So in this topic, we saw about the frequency analyzer because the electronic project control system, the signals are really combining with the different share of the signal coming out or different frequency signal coming out. So the two masters of the electronic control system, you also need to analyze the kind of the signal, kind of the frequency. So that your process control is that you only want to control with the one signal, but if it is combined with the harmonic, in this case you can know whether your process is clear or not. So that there are many harmonic, how to fade out of the harmonic, you can design the appropriate fade out system. Harmonic means that a complex of periodic waveform may be analyzed as the number of the harmonically rated sizes for the wave. So this means that complex waveform means that this is you can see the waveform like this. So this one is a node form a shape. So that waveform can be analyzed. So in this case, that waveform may be combination of the fundamental frequency. So this is F1 plus second harmonic F2 plus third harmonic F3 like this. So this waveform is equal to the combination of the standard waveform. So this we call as F complex. Maybe the F1 plus F2 plus F3 like this. So those waveforms we call it. This one is the F1 the fundamental. And F2, F3 are harmonic. So second harmonic is the line is fundamental frequency value. Third harmonic is fundamental frequency value. So by combining the second fundamental and the second harmonic, so you can get this different complex waveform. So the mean is we can analyze the complex waveform through this standard frequency. So in this case, we use the frequency analyzer. Frequency analyzer, all the frequency analyzers are sometimes you can see the skin like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many particle bar you see? If you see the particle bar, there will be the fundamental frequency. And this is the second harmonic, third harmonic, fourth harmonic, fifth harmonic, sixth, 7, like this. So in this case, there are the frequencies that there are 10 frequencies that make a combination. F1 is the fundamental frequency, 2, 3, 4, 5, 6, 7, 8, 9 are the harmonic frequency. So that when the waveform is combined with the harmonic, you can see the frequency analyzer. So this kind of frequency, if you use the cathode ray also, so you can see the waveform like this. This is a complex waveform. So that if you not sure about how the frequencies are combining, how many harmonics are included, so you have to use the frequency analyzer. You set this waveform into the frequency analyzer, so you can see the particle line. So by seeing the particle line, you can know how many the value of the fundamental harmonic, second, third harmonics are included. So after you know, you have to you need to subtract the second harmonic or third harmonic. You have to design the appropriate filter. Filter design is a filter is the capacitor. AC is equal to 1 by 2 by SC. So depending on fundamental frequency value, you can select the appropriate capacitor value. So by selecting the appropriate capacitor, you can eliminate the harmonic frequency. In this case, you have to utilize the high pass filter or the low pass filter or the band pass filter. Those filters you have to utilize. So I given you in the analog electronics. So those kind of filters are utilized to suppress the unwanted harmonic frequency. problem. The waveform has a period change of 40 milliseconds. When you calculate the frequency of the fundamental, second, third, and the full harmonic. So the T is probably to the fundamental frequency is usually 1 by T. Where we can calculate fundamental frequency. So we can calculate 1 by T. So this is the 1. Like T is a 40 milliseconds, 40 is 10 power minus 3. So by solving this one, you got the thing is 25 Hz. The fundamental frequency is 25 Hz. Then you can calculate the second harmonic. Second harmonic. So second harmonic is a 2f. So 2 multiplied by 25, you got the 50 Hz. And third harmonic. So that harmonic we can calculate 3 multiplied f. So 3 multiplied 25 to 75 Hz. And the full harmonic. So 4 multiplied f. So 4 multiplied f is 4 multiplied 25. So you got the 100 Hz. So by this way you can calculate the fundamental, second harmonic, third harmonic, and the full harmonic. So fundamental is normally one waveform. Second harmonic is in the one period there will be two waveform. Third harmonic will be three waveform. Full harmonic will be 4 waveform like this. So in this case, waveforms can happen. So those are kind of the waveforms that we can make the classification. Those waveforms can be classified as a sine wave or square wave or the white noise, speech, music, derivation, random data. Those are the kind of the waveform. So we also have to know that transmission. So bandwidth. Bandwidth means the good transmission for the off frequency, where is the signal power spectrum is a significant. So this is important for the bandwidth system. So in this case, a specific band need to be passed through by the system. So that in this case, we have to utilize the bandpass filter. Bandpass filter is the within the minima to the maximum frequency. So specific band of the frequency can be allowed to pass through. Use as a signal system. So here are some base band. Base band means the minima and the maximum of frequency can be allowed to pass through the particular packet. So this is the bandwidth, appropriate bandwidth. So appropriate the minima and the maximum frequency should be allowed to pass through the packet. So all the circuits are designed, all the control circuits are designed to pass through the particular frequency. So particular minima or maximum frequency. So this is we call it a base band. So base bands are we can represent. Base bands got the two kind of frequency, F1 and F2. So F1 and F2 can be represented by this way. So this is F1 here, so F2 here. So this is a sample representation of the base band. So this is a sample representation of the base band. Another way we use the spectrum of the power trace. So that when you make the controller will use the power. So those are the continuous power. So those power traces are we can calculate. So this is the path here. So this is the duration we can go into between T, and this is the width of the path where is the tau. The T is this is for the period, and tau is a pathway. So T is a period. T is a period, and tau is a pathway. So we can calculate this waveform. We can utilize for the sine h by h star. So when you want to design this waveform, so we have to use the function sine h by h star. So correspond to frequency 1 by tau. So this pathway we want to explore the pathways for the curve. So the pathways are different. Pathways you will see that for the pathway, I will only give you the one pathway. But all our paths are got a different pathway. For example, this one got this kind of waveform. So this is the down 1, down 2, down 3. So those are different pathways. So those different pathways are supplied by the pathway. So we need to plot the graph for the pathway. So in this case, we have to draw the sine h by h star. By drawing the sine by h star, you can plot the different paths. So in this case, you can see that the graph will be like this. So this graph will be 1 by t, 1 by t, 2 by t, like this. So that will be the t by tau, 1 by tau. So that will be this height can be like this. So this guy is a sine h by h star. This is that we can draw the graph. So this is the pathway that we can draw the graph. So sine h by h star. So that this guy is we have to t is 1 millisecond, tau is 2 millisecond. So we have to locate the 5 kilohertz at the first zero of the graph. So firstly we have to calculate the sine. So 1 by t you can calculate. So 1 by t is the frequency f1. So this is a 1 by 1 millisecond. So this is because the 10 power 3 half for the 1 kilohertz. So 1 kilohertz you have to put the position 1. So in this case, we also need to calculate the tau. Tau is the frequency for the tau. So f is equal to 1 by tau. So 1 by 0 by 2 millisecond. Y into 10 power 3. So that will be the 10 power minus 3. So that will be the we got the 5 kilohertz. So 1 kilohertz corresponding to 0.1, 5 kilohertz corresponding to 0.2, 0.5. So on the graph you can put the 0.5. So 1 kilohertz corresponds to 1, 0.1, 5 kilohertz corresponds to 5. So this 5 is here. This point. So by this you can locate the point on the graph. Path energy. So path energy is path are coming out from the process controller. So in this case, we have to calculate the one path. So this is the tau. Tau will be the 1 by tau. So from here to here, so that will be the most of the energy of this is the pathway. So this is the most of the path energy. So most of the path energies are correlated to the area above the line. So between the horizontal frequency is the frequency line, and vertical is the energy line. So we calculate the one pathway. So the above the line, the area bound by the curve and the horizontal line. So those areas contain the most of the energies are stored by the path, carried by the path. So the next one is the harmonic distortion. So harmonic distortion means that we can write the fundamental frequency. So V in is equal to the sine omega t. So this is for the fundamental frequency. V is equal to sine omega t. So this is fundamental. Then you can calculate for the harmonic frequency. The harmonic frequency means that when you contain V in is equal to A1 sine omega 1 t plus A2 sine omega 2 t. So those are we call the harmonic. So only A1 sine omega 1 t will be the fundamental. After that, those frequency values are the harmonic frequency. So now we can see how the harmonic can happen. So harmonic can be produced by combining the fundamental waveform. So the different frequency waveform. So in this case, fundamental frequency will be 1 kilohertz. The sine wave and the 10 kilohertz sine waves are make the combination. So in this case, what can happen is first is the fundamental 1 kilohertz and a 10 kilohertz. They are the original frequency. in this case, harmonic can also happen. So 1 kilohertz for the harmonic. So 1 kilohertz, 2 kilohertz, 3 kilohertz, 4 kilohertz, those are the harmonic of the 1 kilohertz. So the 2 kilohertz, 3 kilohertz, 4 kilohertz. So those are the harmonics of 1 kilohertz. And similarly, 10 kilohertz they also called the harmonic. So 20 kilohertz, the 30 kilohertz, the 40 kilohertz, they are the harmonics of the 10 kilohertz. So in the meantime, they can interact with the modulation. Interact. So this means that 1 kilohertz and 10 kilohertz are made the combination. So there will be the another frequency will be that 1 and 10 you combine it, they will say the 11 kilohertz. Or 10 minus 1, there will be 9 kilohertz. So 9 kilohertz and 11 kilohertz. They are happen according to the frequency equation F1 plus or minus F2. So this is we call it second order intermodulation. So originally the 1 kilohertz has 10 kilohertz. So the 1 kilohertz F1 and the 10 kilohertz has a F2 can make it a plus or minus. So plus or minus means that you add in the original frequency, that will be the modulation. So modulation is important for the carrier transmission where we make the process controller system. Sometimes as your control system, the controller will pass on the process. In this case, you will put the frequency onto the carrier frequency. So by adding the fundamental and the carrier frequency, we call it modulation. So this modulation system, so that 1 and the 10 kilohertz are modulation, there will be the 9 or the 11 kilohertz. So F1 plus or minus F2, we got it. And in the meantime, you also make the second order. So this is a 9 kilohertz and the 1 kilohertz can be plus or minus. And 11 and the 10 kilohertz can also be the plus or minus. So then will be the F1, F2. So this is for example, you call the F3, F4. So that you can also make the F1 plus or minus F3 or the F4 plus or minus F2 plus or minus F4. So this is we call it third order intermodulation. So by adding the F1 plus or minus F3 and F3 plus or minus F4, first you got the frequency with the 8 kilohertz, 12 kilohertz, 90 kilohertz, and then 21 kilohertz. They are adding can be like this. They are successive functions. So when we're making the frequency, although you want to combine only the fundamental frequency, two frequencies combined, but the successive action can also happen. Although you want to combine only the F1 and F2, but the F1 and F3, so F3 and F4 will be combined. So those are the frequencies will be included in the system. So this is because of this one, we need to filter out the unwanted combination of the frequency. Only one we want the modulation, F1 and F2 combined, but all those successive combination need to be eliminated. So that in this case, we have to design the appropriate filter to eliminate the unwanted combination of the frequency. All the mathematical formats we call the mathematical formula. So those formulas you can see on the notes, but those formulas I teach in the E26. So all the way for and the appropriate math formula. But I'm not teaching the math for this unit, but so E26 I will teach in the those formula. So now I go to the filter. Filter means those harmonic frequency need to be eliminated. And one the combination of the modulation of frequency need to be eliminated. In this case, we have to utilize the filters in the process control system. So filter can be the low pass, high pass, band pass, and the band stop filter. So now I will more emphasize on the kind of the filter. Because in the control system, the filters are the important aspect of the control system. Filter firstly we talk about the low pass filter. Low pass filter means that only the low frequencies need to be the pass through. High frequencies have to be eliminated. So this is the voltage gauge. Vertical axis represents voltage gain. Horizontal axis represents the frequency. So we can see the line of frequency. So this is a pass band. So this is a stop. So low pass filters are you can draw a diagram in the control loop. In the process control system, low pass filter is eliminated. So higher is a cross and a lower. So this is the low pass filter. Low pass filter means this is the low frequency can pass through. High frequencies are upper frequencies can these are stop it. So this is for the low pass. And then we can draw the high pass filter. So high pass filter can also be draw in the here. This is the vertical voltage gain, and this represents 0, 1. So this is stop and the pass and a stop. So in this case, at this frequency, you can also draw for the high pass. So this is the input here. So at high frequencies allow to pass through, low frequencies stop it. So this is for the high pass filter. And another one we can also do the band pass filter. So band pass filter means the particular band need to be pass through.
Has three little ways.
Yes. So this is three ways. So this is kind of stop band, and this is a pass band, and also stop band. So in this case, we can draw the diagram for the band pass filter. So middle one, higher and the lower need to be eliminated. Only the middle frequency has to be allowed. So this is the band pass filter. And another one is the band stop filter. So band stop filter is a vertical voltage gain. And horizontal with the frequency. So in this case, pass band here. Only the display. Then we will stop. And then you pass again. So band stop filter, you can draw the diagram here. So band stop alternate like stop it and higher or the upper lower can be allowed. So those are the band stop filter. So in this case, those are the diagram of the low pass, high pass, band pass, and then the band stop. Okay, how we will make that physical design? So low pass filter, we make the design. So in this case, we draw the low pass filter as electrical connection diagram. So this is the low pass filter. So this is resistor, and this is capacitor. So low pass filter design. So low pass filter design, you can see the voltage gain dB here like this. So this is the gain. And fundamentally with the frequency F. So that will be the stop, critical frequency FC. So this is for the low pass filter design. And although the high pass filter, you can also design a frequency here. This is capacitor, this is resistor. So in this case, we can draw the diagram like this. So this is FC, and this is the T, F. And this is a vertical is a voltage gain. So low pass filter and high pass filter, we can draw like a circuit diagram like this. When we are making the signal system, control system, then with the two kinds of the signal can happen to analog and the digital signal. So that we can design the analog signal. So this is for the vertical is a voltage. And this one will signal will be like this.
Will there be a voltage gain?
Yeah, voltage gain. So horizontal with the tie. Voltage gain means the ratio between the output and the input voltage.
So what happens band pass filter? You're saying there's a voltage gain associated with it.
Yes, band pass filter we can draw a band pass filter like this. So this band, so this is band pass filter. pass ways that we have to utilize for is combination of high pass and low pass to get the band pass data. So analog signal by this way, and we can also see the digital signal. This is for the digital. So analog and digital signals can be represented by this way. So in this case, we also utilize for the modern. Modern means that we input with the binary voltage, output with the analog signal. So this is the modern. So input is a binary voltage. The output is the analog signal. So this is the output signal. So this is for the binary modern. So when you are the signal, analog binary signal is a passing through the modern, output will be the analog signal. Especially we can utilize for the computer system. So computer systems are the input, the computer output will be the digital, and then the alpha passing through the modern, that will be the analog signal. So in this case, our control system, we can utilize the modern to interface the computer. So that this one, you use the computer here. So this computer is connected with the digital transmitter. Then output with the digital signal. So this is one. So in this case, when you are using for the degrading means when you send a signal over the processor control system, signal sound will also be a signal value will be going down. So in this case, we have to use a regenerator. So the analog signal we can amplify by the amplifier. So digital signal, we have to use the regenerator. So amplifier amplify the weak analog signal. In the meantime, regenerator is the upgrade the weak digital signal. The next topic is a pulse modulation system. Pulse modulation system means in the transmission system, we also sometimes we have to utilize the analog signal. Sometimes we have to transmit by the digital signal. So in this case, in the process control system, normally the easier one is we control the analog control system. But the analog control system is subject to the digital, subject to the noise. So in this case, we have to utilize the digital transmission. So in this case, the conversion from the analog signal to digital signal, we call the fast pulse modulation. So we change the analog signal is encoded into the digital signal, and then transmitted over a digital transmission medium. So this is we call it the fast pulse modulation system. We can noise and interference can be eliminated. So when we making a control system, the important one will be that control system must be free from the noise or interference. When some control system are very important control system, so they are very sensitive. So any noise interference can damage the control, the overall operation of the main functioning of the control system. And because of this one, although we are using the shield wire means the shield wire can protect the electromagnetic interference, but not always they are 100% satisfactory. So in this case, not only we utilize the shield and the protection wire, we also have to utilize for the fast pulse modulation system. Fast pulse modulation system, instead of we using the analog, we convert it to the digital, and then we transmit the digital, and then we can decode that back to the analog. So by this way, we can more effectively utilize for the process control system. So now we also show you how to encode to the PCM. These systems are basic PCM. Start with fast pulse modulation system. So encoding process involves the following steps. Low pass filter in. So it is ready to utilize the low pass filter. and then the sampling. So you get to sample and the analog digital conversion. So 3 steps need to be performed. So now I give you the diagram for the low pass system. So firstly we use a low pass filter. Low pass filter means a 5 pipe. So this is a low pass filter. LPS. LPS is a low pass filter. And then we can use a sampling network. Sampling is similar to a switch. So this is a sampling. And after sampling, we have to change the analog to the digital conversion. So I already given you the analog to digital converter. So digital to analog AD conversion. So AD conversion system. So this is the AD conversion. So analog conversion means this is analog means for the AD conversion, quantizing and encoding. Quantizing and encoding. After this one we send to the transmission system. So this signal are sent to the transmission system, and then this one is we can change back to the digital to analog conversion. So this is also we call it decoding. And then after this we can utilize the analog data for low pass data. So the output. So this is the process for the PCM encoding process. So firstly, the low pass data to high frequency harmonic frequency are eliminated, and we use a sampling network, and then we change back from the analog to the digital. So this is the quantizing and the encoding. Then we can transfer the digital signal over the transmission system, and then at the end of transmission, we convert it back to the analog by the DA converter, and there's a low pass data. We have supplying the output. So regarding the analog to digital, digital to analog, I've already given you the digital system. So those systems we utilize because in the control system we need to the control signal need to be eliminated, need to be free from any noise or any interference. This is why we have to utilize for the digital PCM system. Okay, so when we make the PCM system, so sampling is usually we can utilize by the switch. So only the one specific case that we have to utilize the sampling. So now I give you the more detailed diagram about the low pass filter. These are the 3.4.5. So in this case, normally the frequency range is start from the 300 to 10,000 Hz. So this one will be the 3400 Hz. So around the standard frequency, beyond this one, the high frequency has to be eliminated. Okay, so this is the thing. Another thing we also know the sampling. So how the sampler is working? So sampler is similar to TI input, and this is will be the switch. This one will be rotated by the motor. So motor is a sinusoid waveform. So this sampler is similar to the TI. So this will be the output. Although input is a sinusoidal waveform, but output function is depending on this one. This one and this one start, so this one will be closed. So this output function will be like this. So normally waveform will be coming like this. So this is for the sampler. Sampler function is we change it for the analog to the digital system. We use this sampler. Input is although input is a continuous sinusoid, output waveform can be like this. So this is the part. So output waveform will be the digital format. So this one we can utilize for the digital system. So now we also utilize for the control system. Control systems are we also need to use a multiplexer. Because of the controller loops are there, so all the signals are coming through the one signal line. So those signals need to be they are several sources are using this signal, so we have to utilize a multiplexer. So in this case, we use a time division multiplexing method is utilized to pick up the appropriate signal, so appropriate channel system. When we are making the controller design, the control signal is normally passing through the transmission media. So that in this case, we have to utilize the appropriate data system, appropriate control system. So those control system signal must be free from any interference. And this is why I give you the idea how we process the electronic signal. So those signals are utilized for the controller. Okay, the next one I teach you the Samos control concept. Those control concepts I ever given in the 826. Here now I will make the most of the writers are the deep writer selections. So those concepts, control concepts will include the transducer, industrial transducer, control system, final control element. In the middle, I will be given you the process control loop. So process control loop setting, the process control loops are defined. Those things I will be given from the week 10 to week 12. As you this case, we talk about the process control system. So we made the process control introduction. I teach you the relevant digital system. Now from here now to the what we can do the more details of process control system. So process control system will consist of the transducer, industrial control, final control elements. In the meantime, I also give you the control system concept. So more detail about the control system concept. Those are process control system I ever give you some idea in the last semester for the H26. But here is we make a more emphasize. And also we will also be after that we will also be drawing the various control system, designing the control loop. So designing the control loop function, so analyzing the control loop, those are where these are running. So regarding the industrial transducer system will be it can it consists of the sensor and the amplifier. Sensor means that it senses the input of temperature or the pressure or the frequency or the light. You are sent by the sensor. So that the signal produced by sensor can be the weak signal. So that when we want the signal to be enlarged, so in this case we have to utilize the amplifier. So this is why we have to use the sensor and the amplifier together. So this is why when you are using the control system and the last semester you already learned the H25 and 26. So this is a single phase and three phase. So I give you the analog electronic, analog amplifier. So those things are the very associated with. So the control system, we ever utilize the amplifier. The reason is that signal sent by the sensor, sent and produced by the sensor will be weak signal. So this signal may not be so high enough to transmit it over the transmission line or transmit the system or the fed to the computer. So this signal needs to be amplified. So the sensor and the amplifiers are combined in the transducer. In the transducer system, we can utilize for the closed control system or the programmable controller system. Now normally the industrial quantities are sent by the transducer, so they are provided through the analog or the digital digital format. So the digits are supplied to the CPU or the PLC system. Then the control system signals are provided through the analog by the ADC, DAC converter, so that we can utilize for the industrial control system. PLC system. So this is the one format of the PLC system here. So this is the input and the output module. So those are input module, and this is the output module. Here we use the switching system. So those things are input and output module. So here you can see for the monitor. So all the signals which stay close, you can monitor from here the light. So both are input and output module. We need we need a power supply. So we use a power supply. So power supply 240 volt converted to the 12 volt, and then we supply to the input-output module. In the meantime, this input module we connected to that you have to interface to the computer. So those signal we have to use the interface devices. So interface devices we use the computer system. So computer system in the input maybe analog. So those analog can be converted to this for the interface devices. So those interface devices those switch. Those are you use this interface. This interface connected to the computer. So the computer, any computer signal, they can transfer to that and they can operate the those switch. So the computer also requires program to control the those system. So the for the digital control PLC system. So input-output module is important, and this input-output and the interface module. So interface module must be connected to the PLC's computer CPU. So they also require the supply. So the power supply with the DC supply is given. So this is the input. Inputs can be connected to the process system. So input module. So those are input module and output module. So they are connected to the PLC CPU. So this PLC CPU, we need the interface devices. Those are the interface devices to compatible with the PLC system. So the whole PLC also requires the PLC control. So in this case, you use the S7 or the S5, or I also give you the TS31. Those are program software. Those program software control the input and output function. So those input output function, the program software only in the computer. So we want to drive the output system. In this case, we have to utilize the input output module and interface. This is a typical PLC control system. Temperature measurement system. I've already given you the details of temperature measurement in the last period. Now I just summarize. So in this case, we measure the temperature. So in this case, there are temperature and heat we can measure. So temperature measurement system is the temperature is we analog to the body, and the heat is a current. So when you making the variable temperature measurement, temperature is a correspond to the body, and the heat is correspond to the current. So by this way we design the appropriate computer. We have measured the temperature in the industry, so that the ranging from the minus 267 degrees centigrade to the plus 7,500 degrees centigrade. Especially that very heat, metal processing plant, in this case temperature is very high. So we use the temperature measurement system. We use the thermocouple. We use the resistant temperature detector, so that we can utilize process the coefficient, the thermistor. So we use the thermocouple, resistant temperature detector, and the thermistor to measure the temperature. This is like it. Here we use the thermistor. The thermistor, here we use the potentiometer. And this is made one we use the galvanometer, the switch, and the galvanometer. So this is for the resistor R1. So this is the resistor R2. So in the beginning of the lesson, we use the analog signal processing. So I give you this kind of bridge. So this is we can utilize for the thermistor. We use the thermistor here, and then we can balance the bridge, and then by this way you can measure the temperature. So this is we use for this one. This is for the we call the thermistor bridge. Also, we can also utilize the differential thermistor bridge. Differential thermistor bridge means different temperature can also be sent. So in this case, here we only use the single thermistor. We can also use the double thermistor. So we can form a differential thermistor. There are two thermistors here. So thermistor. So this is also thermistor. So two thermistors we connected, so we can also use the galvanometer, resistor, and a switch like this. And then we can use like one of the potentiometer, and this is the phase resistor. So this connection we connected to here and supply voltage. So this we can potentiometer. So potentiometer, so this is a favorite system. So thermistor, this is we call it differential thermistor bridge. So we use more as in the temperature measurement. So temperature measurement system, we can use the thermocouple, or we can use the resistant temperature detector, and we can use the thermistor in the industrial temperature system. Industrial temperature system, we ranging from the minus 267 degrees centigrade to 7,500 degrees centigrade. So this is for the temperature measurement. So in the way that we also utilize for the force measurement system in the industry. So we use a strain gauge. We use a strain gauge to measure the force measurement. In the meantime, we also utilize for the strain gauge system. So strain gauge system can use two kinds of gauge. One is the bonded and the unbonded gauge. So those bonded gauge can utilize for the grain system. So we can use bond wire. Unbonded gauge also utilized for the small displacement measurement. I give you the notes for the strain gauge. For measurement, you also utilize a strain gauge. So strain gauge, so I draw the strain gauge. So there are two kinds of strain gauge. Strain gauge with the bonded and the unbonded. So the strain gauge of the strain or the load or the torque, acceleration and vibration on the object can be determined by the measuring the displacement of the predetermined point. So the amount of the displacement is very small, so just a micrometer. So in this case, a sensor commonly used to determine the displacement is the resistance strain gauge. So resistance strain gauge is utilized to measure the force. So in this case, this is for the construction on the strain gauge here. So then we use the terminal. So then we spring. So when you change this is the pressure. So the spring resistance will also be changing. So the change of the resistance you can connect it to the electrical supply system. So by the way, you get the supply system is going to use the bridge system so that we can use this change of the resistance is related to the resistance changing so that we use the bridge system to determine the appropriate measurement. Typical application of the strain gauge system. Strain gauge will be this is the insensitive, but this directional force will be sensitive. So this case will respond to this directional force. So that there will be two active gauge and the timing gauge. The two gates are usually included. They are connected to the electrical circuit. So typical application of strain gauge is for the grain system. So this here we apply the strain gauge. The weight is important. So the weight needs to be adjust. When the weight too high, so grain can be damaged. This is why it's extremely important for the electric grain system. So that this grain system we utilize a strain gauge here. So this force, so the force when we put the force, so this will be progressing like this. So that this measurements are good thickness that you can put into this gauge. So that you can indicate. So basically you can know the phase or the temperature level. Yes. And the pressure. So in this case we use for the strain gauge system. And similarly we also utilize for the strain gauge for the motor system or motor shaft. So in this case when you use a shaft, normally torsion can happen. Because of the distance you use a mesh this is one shaft here. So very big motor system, this is one shaft and another shaft are made a couple. So they are coupling. So this is the two things that we can put. So this is we use it here with the apply load. Apply load on the this is we use a bearing. Here's a bearing. So bearing. Then so this is a bearing here. So here we use about the bearing also. And so this side, we join it like this. So in this case, we use a strain gauge. So this strain gauge, this is the one shaft and another shaft. Two shafts are joining together. So this is middle point. Middle points are the suffer the maximum strength. So this is the one shaft measure. This is the steam turbine, or another shaft is a generator. So two shafts are joining point. We use this is important point. So here the suffer is the bearing. So in this case, we attach the strain gauge like this. So strain gauge is we attach like this. So here we put the strain gauge. So strain gauge we connected to the connection. So this strain gauge we connect like this. So we connect the strain gauge here, and here we can attach to the brush. So this is we use the brush. So this brush then we connect to the electrical circuit. So this is a brush we connect to the electrical circuit. So this is two measurement circuit. So this is for kind of the strain gauge. Because of the when two loads are running the machine, two shafts are joining together. So two shafts they make the torsion. Torsion means that turbine is running the generator. When the generator also suffer the load because of the when they are supplying the electrical supply, so electrical loads are placed on the generator. So generator load and this turbine loads are between two shafts of there is a critical point. This critical point this is the maximum strength. So in this case, the strength level need to be measured. So in this case, we insert the strain gauge like this. So by inserting the strain gauge, so those strengths are compressing the strain gauge. So strain gauge make the indication so that you can know that which load level should be the safe load, which load level will be the unsafe load. So unsafe load you have to reduce the load. Because this one is a very important. When I walk on the ship, the one ship, what happens is that one side we make the generator. So diesel generator is driving the diesel engine is driving the generator. So this generator, two generators need to be synchronized. So one side is the engineers they make the wrong. When they put this two generators synchronizing is one machine another pressure is 180 degrees of this. That time one machine can be driven as a motor. So that time the straight on the thing. So as well as what happens, one machine began a motor. Motor began so they make the back running so that all the diesel generator, all pressure bar, everything coming out. They broke it. This is a very important aspect. This is why we have to utilize a strain gauge appropriate system. So we use a strain gauge in the crane system or the carpet system we use. So by this figure you get and we can know that how much load should be affected and how much load is dangerous. So strain gauge can be the bonnet or the unbonnet system. So in the meantime, you also need to measure the speed. So speed is overspeed is also dangerous because of the toe bearings. Toe bearings are when the overspeed happens, bearing can be melted out because pressure is too high. Pressure is too high and the bearing can be melted out. So in the ship, mostly the bearing is usually damaged, especially for the very stormy weather system. So stormy weather system means that when normally the ships are like this. This is ship here. Normally this is ship radar and this is propeller. Like it. Okay? Normally propeller is under the water. Because the ship propeller is they are passing through the water so that they already friction. So normally good weather, no problem. This is a propeller is under the water. Now sometimes what happens is a very high tide. High tide will be there. Tides are very high. So that this propeller is this ship here. So this propeller can be like this. They are no more in the water. can happen like this. No more than what I mean, this program will be very fast. So when this kind of a very big rolling happens, the good program is a very faster, and then sometimes like it can is a meltdown. So it is that we ever see things that get very meltdown. So what happens is that in this case we need the control. As soon as the ships are stabilized above the water level, the speed need to be immediately put out. So in this case, computer system reduce the speed instantly. So this is the way that the control system we use. So that the bearing is very important. So because of that, when the temperature is too high, bearing can be the meltdown. It's a second generator can be the direct drive or the bed drive or the gear drive. So in this case, your machine, you see that the machine you stand through all to the predicator. So this is a gear drive system. So this is you can see the left side, middle right one way that the three-phase induction motor, and middle one is the two windings of generator. So this is a three winding armature winding, but the left one way is a permanent magnet. So this permanent magnet will be a tackle. We can use as a tackle generator or the P8 exciter. So later we will study the characteristic of the P8 exciter. So those excitation will give to the supply and we can study what happened, and also the rate speed and the voltage generator will be measured. So those tackle generators are utilized especially for the speed measurement. We change the analog to the signal. So how we change the encoder means, this is for the encoder. So this is for the watching here, this is we use the sensor. And this is we call the output. Output with the pathway like this. So this is why you connect it to the motor. So when there's a light coming here, this light, so this light will be sensed by the sensor. So output pathway is coming out will be like this. So we use all the encoder. Encoder system will be the digital to analog to digital conversion. So this is what light. So analog to digital conversion system we use for the encoder. In the meantime, we also use the precision potentiometer, so position measurement. So position measurement we use for the position transducer. Position transducer. So they measure for measure the shape position of the object can be measured by the precision potentiometer. So they can meet the position, the transducer can be three types. There will be precision potentiometer, synchro, and encoder. Precision potentiometer, synchro, and encoder. So there are three kinds of things. So in this case, this precision potentiometer we use for this system. So this is for supply. Supply is 10 volt, and then here we use a wiper arm. And this is for the output voltage. So this is for the precision potentiometer. So in this case, we can apply for the wiper arm like this. So in this case, we use a wiper arm like this. So by traveling, we can also change. So in this, we use it for the synchro and the solver system. So input position and the output position. So input position will be like this. So this is for input. So this is transmitter. The transmitter is a producer the input. In the meantime, we use a receiver. So this is the output receiver. So this is receiver. So when you change the input position, the output will be they follow. So this is the input and output. So this is we also use a synchro. So synchros are utilized for the position measurement system. So position measurement system, we use a synchro. Synchro means that we adjust any change in the input position, output will respond to. Similarly, we use a position meter. The precision position meter also utilized for the position measurement. So position measurement, we use a precision position meter and the synchro and the angular system. So by using the angular system, analog to digital signal can be converted. So those are the basic of the transducer system. So transducer system create ITU that are temperature measurement, flow measurement, and the speed measurement, and the position measurement. Those kind of transducers are utilized in the industrial control system.